Good morning. This is the rates of reaction experiment. Okay, so the reaction I'm going to do as a demo involves magnesium ribbon and hydrochloric acid. So you don't need to, you're not going to do this experiment, you're going to do a slightly different one. You're going to use hydrochloric acid, but you're going to use calcium carbonate, which is like little stone chips, calcium carbonate chips. The magnesium is a good demonstration. So, what would the reaction be? Or this is going back to chemistry. What's the possibilities here?
Like fizz.
Single replacement? Okay, what's the magnesium going to replace?
Cl.
Does this gain electrons or lose electrons when it reacts? It's a metal. Loses electrons. So this can lose an electron, this can gain an electron. So which one's going to replace? Okay, the H. So we've got an Mg and a Cl, and then we've got an H over here. So initially, that loses 2 electrons, that only gains 1. So what's the formula?
Mg2Cl2.
Excellent. And then this is one of our special ones. Is it H or is it something different? H2. Yeah, it's one of the diatomic gases. Okay. How many magnesiums?
1.
How many magnesiums?
1.
Okay. How many H's?
2.
Ooh, so we need to do something here, don't we?
2
In front. That makes 2 Cl's.
And
Good. And if we were going to go a step further, we would put the state of matter. So this is a solid. This is a solution. So aqueous for solution. You will find, and I'll show you, this is a solution, and this is a gas. Okay, so there we go. That's a full chemical equation. And this is how I'm going to do the experiment. I'm going to use I'm going to measure it. There you go. Thumb. And I'm going to use about that. I'm not measuring it very accurately, am I? No. Okay. That's something that you could think about. So, initially I'm just going to show you what the reaction looks like. So we're going to use little test tubes. You're probably going to use bigger ones. And you'll see why in a second, but I'm going to fold the magnesium into a little ball. So I folded it in twice, and then I'm just going to kind of curl it up so that it's kind of squashed a little bit. So I'm just going to show that to the camera, so that people know what to do. And then I'm going to use this squashed up piece of magnesium in my tube. Actually, I'm going to take it out of the tube. And I'm going to use 2m. It's molar. It's just a way of measuring the concentration. So I'm starting with 2 molar of hydrochloric acid. And I don't know, I'm going to put... Actually, we don't even need the dropper's useless. Let's just pour some in. I don't know. I'm going to go about half a test tube.
Accuracy.
Okay? I'm not being very accurate, Rocky. You can think about that. And then,
Rocky goes home and
to start the experiment, and 1, 2, 3, go. Okay.
That bubbly.
What do you see, first of all?
something coming off the top. That's probably reaction. The
Right. I know you see a reaction. What do you see? Describe.
Bubbling.
Bubbling? Could you hear anything?
Yeah, it's
Fizzing?
Does it smell like anything?
Nick, hold that.
Is it warm? It's a bit warm, yeah.
That's getting, Jordan, feel it right at the top, where it's bubbling. No, where it's bubbling.
Oh, yes.
Pretty hot, right?
Oh,
Rocky?
yes. That's quite warm.
That's
Okay.
quite warm.
We've also got, ow, that is quite warm. The top part, what do you see?
Condensation.
Yeah, okay. So that's obviously because this solution of HCl is in water. So that top part is bubbling, the heat is making the evaporate, and then it's condensing on the sides. Now, there's obviously gas escaping, there's bubbles. It is. So There we go. Okay, so what I want you to do initially, I'm going to give you this sheet of paper, and all I want you to do is find a little space and just jot down this reaction and then quick observations. What did you see, hear, those that touched it, and you all could use that information. What did you feel? And then think about, how do you think you could measure the rate of how fast this goes? So, by rate, we always have to do something over time. So something has happened over time. Well, what do you see compared to the start?
Is there less of the solution?
The solution is probably about the same, Angus. What about the... Nico, can you see the magnesium in there now? Or is it...
I cannot see it.
Okay, so it's kind of gone. So the magnesium disappears over time. The magnesium gets used up. In this situation, in this one, we've got way more HCl than we actually need. Okay? That's just a fact. So the magnesium disappears. So you've got to think about, what can I measure over time? What's happened to the fizzing? Okay, so you could think about fizzing over time, all right? There was a gas being produced. How could you measure the amount of gas? Okay, so you're going to think about these. How could you potentially measure the rate of this reaction? So initially, use the back of this one. The rest of this is for the next 3 parts of the demo. Okay? Or shall I just do the first part? And then you can write that on the back at a later time. Let's carry on. Okay. So, all right. The factors which affect the rate of the reaction. So, the first one that we're going to look at is we're going to take some HCl, just in our bottle, like that. And we're going to put some HCl in here, but I'm only going to put about half in, not even that. And I'm going to dilute it with some water. About okay. I don't. Again, did I measure that dilution? No, I did not. Okay. But what I do need to do is I need a little note, and I need to put. That was my 2M, and this is my dilute HCl. Because I want to make sure that I don't mix them up, right? Okay, because I might need to know. Because they look the same, don't they?
Yeah.
Okay, so labeling things is probably a good idea. Now, let's go. So this one, and so the same length. Fold them both up. Fold and roll.
Show the camera.
Fold and roll.
What happens if you put magnesium into just water with a super reaction?
Very, 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 very slowly.
Okay.
Yeah. In hot water it goes a bit better. In steam it goes really well. So this time I've got my 2 tubes. I'm going to put one on either end of here. That was my old one. And then I'm going to put my concentrated HCl in this one. And then I'm going to put my diluted HCl in this one. What have I tried to do? Tried to make them the same. Then I'm going to drop my magnesiums in. Okay. What do you see? Concentrated. Oh, what's happened there? It dropped down because it doesn't have as many bubbles on it. This one, there are so many bubbles that are stuck to it and then escaping that it floats. Whereas this one, not as many. It's actually, potentially it looks more. Okay.
Touch and snap.
Comparison.
Oh, that one's a lot more.
Okay. Nick has said that this one, which is the 2, is a lot hotter than this one. Is there any other visible observations that we can see?
Yeah.
Condensation is a lot of condensation on this one.
Well, there's less liquid in the.
Yeah, I wouldn't trust the less liquid thing because I didn't measure it, right? But comparison, Rocky.
That one's like barely above room temperature. That one's like
it's really, really hot, right? This is the same as it was on the previous one. So this is our concentration. So what we got to think about now is why is that? Why does more concentrated HCl go faster than diluted HCl? And I'm not going to get you to, we're not going to talk about that. It's just your ideas.
Oh.
But no, just your ideas.
You said we're not.
You're not going to talk about it, Max. Okay? So that's the first one. Now, Jackson, did that kettle boil or not? This one did.
No, sir,
Right,
it was
this
not
one
plugged in.
No, I don't. So this time, I'm not going to use the concentrated HCl. There's a reason for that. What I am going to do is I'm going to take 2 more test tubes. I'm going to use the diluted HCl for both of them. Because what am I wanting to do? Oh, shoot. A little bit too much in that one. A little bit too much in that one. Close enough. Okay. This time,
Science.
I'm going to put one of them in hot water. Now, I'm going to have to probably leave that there for a little bit. Why?
So it can transfer.
So it can warm up. Okay, so the heat can transfer. Good. So, if we go back to the concentrated and the dilute, the one in the concentrated, the magnesium's almost disappeared. And this one's still sitting at the bottom looking pretty much normal. Okay, so it takes longer to dissolve. Think about that when you're thinking about rates. Looks like I can just chop this one straight in half.
Accuracy.
Super accurate on this one. And fold this one, fold it, fold it, fold it, fold it, squish it, fold it, squish it. Now, what's the difficulty of measuring? What were the things that we looked at for the reaction rate just now? We looked at the fizzing, we looked at gas production, we looked at temperature. Is that going to be a thing this time? And am I going to be able to use temperature to figure out why?
Because it starts at a higher temperature.
Right. If I had a thermometer, what could I do?
You can calculate it. Yeah.
Right. So it is possible, just not with your hands, because it's like, oh, that one's hot. Well, yeah. Duh. Okay. Let's see if this actually works this time. So, into there and into there. Hot one?
They're more bubbly.
Yeah. Both staying on the surface kind of a little bit. They'll probably both sink in a second.
So can I have my view of the...
Can you see?
You can move to where you need
You
to
can
go.
see.
I can.
That does make sense.
This is the hot one.
Like you don't need to be a... You don't need to just sit there.
Thank you.
Okay, looks faster. Okay, so the hot one, bubbling more vigorously. I can't do that because that's hot already, right? I can tell that this one's warmed up, but I can't tell if that's changed temperature or not. If I had a thermometer, maybe, I don't know. Okay, so that's the temperature one. So again, same conditions, same magnesium, same HCl this time, but this time we've got hot HCl. So we've got more energy in that. So you've got to think, okay, why is it going faster? All right. The third one is nice and easy because I can use my dilute. I might have to make a little bit more of it. Let's just make a little bit more of it. Because there we go. The last one. Now, this last one, we've got our dilute HCl. We're not using the 2. I'm going to use 2 of these. This time, I'm going to take my normal folded piece in one side. Okay, but on the other side, I'm going to take, whoops, and I'm going to cut it up super fine. So, whoops, I'm going to lose a few of these, I know, but I'm going to gather them up at the end. So, on the one hand, I'm going to have a little lump of magnesium, and in the other side, I'm going to have little bits of chopped up. This is like,
Confetti.
I'm going to give you a clue here. This is like kindling.
There's more surface area.
Ah, yes. So, Angus, what are we changing?
We're changing the surface area.
The surface area. So this one is squashed, and if I could, I'd get that again, but I don't think I can because that's pretty squashed. Let's just squash it, shall we? Right, that's definitely squashed. And then on this side, gonna have come on. Whoop, okay. Close enough. We're going to have, right, this is where I might need a little bit of help. So, Nick, you're going to take that piece of magnesium and you're going to put it in this side. Sorry, this side.
Okay.
And at the same time, I'm going to do this with these. You ready? Go. Okay.
Wow. Whoa.
Smaller ones are kind of floating around.
In the middle.
Okay. This was not hot, so can we do a comparison? Tate?
Now it's hot. This one is not as hot.
Not as hot. Nick, you did the ones before. Can you tell me if this is as hot or not as hot as the previous?
I would say it's not as hot.
Right. So this is not as hot as the super concentrated one. But there's definitely a difference between those. Yeah?
Good job, Nick.
Oh, it's not super hot. But there's a difference. Okay? So these guys are saying there's a difference. We can see a little. I've actually left a little bit of magnesium at the top. Wouldn't want to do that, would I? Leaving magnesium.
Nick, good job.
No, that was me. That wasn't Nick.
Nick. No, I think it was Nick's fault.
Okay, so then we've got
It was 41.
high surface area, low surface area, going slower. So we have three. So again, we've got to think the HCl was the same there, but we had a screwed up ball of magnesium versus lots of little bits of magnesium. So why is that going faster? The one thing that I will ask you, and we'll get an answer, is what causes a chemical reaction to actually take place? What do you need? You need an exposed surface. You need energy to start the reaction, and ultimately you need a
chemical reaction.
Big bang reaction.
you need a
Big bang.
Catalyst.
Nuclear fission.
Contact.
what? A contact. If the two chemicals don't come together, nothing is going to happen. What if they come together, but there's not enough energy?
Nothing's gonna happen.
Because we don't get over the activation energy.
Yeah.
Okay?
Oh, I remember that.
Right? So, what I want you to do with this sheet, it is in 3 sections. Use the back to think about how you would measure the rate of a reaction. And don't just write down one, write down 2 or 3 different options. And then on the front, there's concentration, temperature, surface area. And there's 3 boxes. The first one is just describe what you saw. Like point form. It's like 3-4 words, that's all. Second one, what do you think is happening in the different ones? So the high versus the low concentration, the hot versus the cold, the high surface area, low surface area. And then in the bottom box, could you draw sort of like a little cartoon molecular diagram to represent hot versus cold, concentrated versus not, high surface area, low surface area? Can you draw like a little molecule cartoon at the bottom? Okay? So let's spend about 15 minutes doing this, and I'll tell you what comes next. Got it? Go.